Always make sure that I am recording it because sometimes I forget. So this is at method, and this length I don't remember, right? The length error. Maybe you are merging two things. I don't know. I mean, who throws it? But just look it up and you will find usually STL library stuff. By the way, remember I couldn't find the invalid argument exception of the bit set yesterday. I mean the documentation was wrong. I found it at some other documentation. So don't trust the documentation that you are reading about C++ on the web. Okay, good. So these are the logic error exceptions. And let's look at the runtime error, overflow error, and underflow error. Overflow is obviously if your numbers are, if you are using two big integers, or if you are using two big doubles. Underflow is your number is very, very close to 0. Okay, very, very close to 0. In that case, there is an underflow error. These are all exceptions. Okay, so remember what I said before. Remember what I said before here. Okay, if somebody throws an exception, you may catch that exception using a reference to the base class. So you might think that if you are catching this exception using a reference to the exception class, base class, you might think that you will catch anything possible, right? I mean, runtime error, logic error, bad type ID doesn't matter, since they all derived from the same base class. You would think that this will catch anything possible, which is not correct. Why it is not correct? Because the user or your client doesn't have to throw an exception that derives from exception class. Okay, so I may just throw an exception of type integer or double. Okay, I shouldn't do that, but sometimes they do. So that's not a good assumption. That's not a good assumption. But if you like to catch everything, then you use this. Okay, catch ... This is a valid syntax. Okay, when you do the catch ... it will catch everything, whatever it is, but it will not know what it is catching. Okay, it will not know what it is catching. So this is a safe way to not to terminate your program if there is an uncaught exception. Usually people do this. Usually when they say try something, okay, catch memory error, okay, I do this, then catch, let's say, bad type, handle it, and then if there is something else I did not know, then I will catch that one too. Okay, and maybe C error, okay, send email to developer. Maybe something like that, right? So this is usually used in these kind of cases. So anything else, I am going to catch it. So when this try block throws something, I will try to catch it using this one. If it doesn't work, then this one. If it doesn't work, this one will definitely work. That's why it's a very bad thing. It's a very, very bad thing. Let me do it with a red pen. It's a very, very bad thing to move this at the beginning of all the catch blocks, because this will catch everything. Once it catches the exception, no other catch blocks will work, because it was caught by this exception block. Okay, so somebody's asking me, sir, could we catch it as a const? Can we catch an exception using the const modifier? Yes, you could. Yeah. But usually the thing is this, okay? When an exception happens, okay, things are going bad, okay? I mean, this is not normal flow of your program. You don't care much about the performance. Why we send constants to functions? We say that I am afraid that this function is going to modify it, or I am afraid of copying costs because it is too expensive, right? With the exceptions, you don't talk about costs anymore because things are not going very well. You run into a problem, okay, you drop your guard and you say that, okay, I am going to handle this exception. As we said before, don't try to handle your regular flow of control with the exceptions. That's why usually we don't use const references with the exceptions, but it is okay, you could use it. Okay. Good. So I guess that's okay. So the standard exception hierarchy is a good starting point for creating exceptions. So make this a habit. Always derive your exceptions from the exception hierarchy. That would make your code more understandable. That's it about the exceptions. And maybe just maybe because it is our book, maybe, I don't know. Let me go over the book's slides a little bit so that you know about the exception handling. So the book starts with a very, very bad example. It's a very bad example. I said it's a toy example, bad example. I don't like it. I hate it. Well, I mean, the book is kind of saying the same thing. It says that this is just a toy example. Don't take it as a serious code. But when I show this to students, okay, some students, for some reason, they only study the first 5 pages of the chapter. And this first 5 pages of the chapter is a bad example. So they don't read the rest of the chapter and they keep using these exceptions in a very, very wrong way. I keep getting this, okay? So this is a bad example. It says that, okay, give me some donut numbers, okay, how many glasses of milk? So it is going to divide this donuts by the glasses of milk. If milk is 0, then I cannot try. But it says that if milk is less than or equal to 0, throw donuts, and it is catching the exception in the same function. So this doesn't make any sense. Okay, what was the idea of using exceptions? Separate your normal flow of control from the error handling. Okay, this is both doing the error handling and the normal flow of control doesn't make any sense. So the normal thing is you call your functions whatever you need. If they are throwing exceptions, you catch them somewhere else. Okay. And if you, for some reason, if you need to throw in exceptions, you shouldn't catch it yourself. I mean, why don't I write these 2 lines, line 26 and 27, here, line 17? It is exactly the same thing. You might say that this is error and this is normal. No, this is not normal. This is error 2. Okay, line 17 is error 2. Okay, so this is a very stupid example, and the book is at fault actually, but the order of the examples given by the book is not in good order. And since this is one of the last chapters, when students study this, they start from the beginning. So don't start from the beginning of this chapter. If you are going to read 5 pages of this book, this chapter 18, read the last 5 pages, okay? Not the first 5 pages. But of course, you should read the whole chapter, okay? The book doesn't say anything wrong, it's just the order is wrong. So I think we talked about it. Catch block and catch block. No problems. Defining exception classes, we talked about it. And this one doesn't drive its no milk class from exception class, but it should. It should have done it that way. Multiple throws and catches is possible. Catching is okay. Okay, divide by 0. Okay. So we always talked about it. And throw list, we talked about it. Throw list summary. Derived classes, we talked about it. Yeah. I think I took this from somewhere else. It wasn't in the book. Okay, so preferred throw catch case here. Okay, so a function throws an exception and you catch it somewhere. Okay, so you call that function and you catch it. This is how we should use it. So function B is how we should use it. And uncaught exceptions, if you don't catch them, they will terminate your program until you set your terminate. Don't use exceptions too much. Okay. Don't use exceptions too much. That's not good. That shows that you have too many exceptions, that you are doing something wrong. Okay, I guess that's it for this rethrowing exceptions. Yeah, we talked about it. High score, I already showed it. So that's it about the exceptions. Mohammed has a question. Can we use ... in void foo throw? No, Mohammed, you cannot use it that way. But if you say void foo semicolon, that's it. That means that function can throw anything that it likes. Okay. So that's what we have been using. That's what we have been using all the time. If you have a function void f, this means that this function can throw anything it likes. There is no restriction. Okay, but if you say void f, okay, throw this means that this function is not going to throw anything. Okay, so if this function throws something, it's a runtime error. So your question is this: can I do this? Of course you can, and you have been doing this for the last year, starting from your first function. Okay, any other questions? Exceptions are very, very similar to in Java. So we will be very fast when we cover exceptions in Java. Okay, so if we are okay, let me start the new chapter, which is about the STL classes. Where are they? Okay, yeah, here it is. Standard template library. Okay, so we have seen a few examples of this standard template library. The ones that we use most often is the vector class. Remember the vector class? What is going on? Didn't I clear all the annotations? Clear annotations, clear all of them. Okay, I did that. Good. So we are going to study these classes in more detail. Well, there are many of them. In fact, if you go to the c++.com and see, some of them are here. We used, which one? We used vector. Okay. There are arrays, there are digs, lists, maps, queues, sets, stacks, and etc. And there are more. Bit set is a specialization of vectors, I guess. I need to read the documentation. And each one has lots of functions defined. So you go there and you read it. But if you look at the vector, today we are going to look at it more carefully. And I think with the vector class, okay, with the vector class, I think today you're going to understand everything about the vector class. Usually I didn't talk about these iterators, and I talked about all of the modifiers and the accessors, etc. But we didn't talk about the iterators. So today we will talk about the iterators. Okay, so let's start. 3 things. First, we are going to look at the iterators. Iterators are, for us, they are almost like, they are very, very similar to, they are almost like pointers. Or sometimes we can say that they are generalized pointers. What is generalized pointer? And we are going to see it in a few minutes, okay? And after that we are going to look at these containers. Vector is a container, set is a container, list is a container, stack is a container. So these are the containers. And there are types of containers like sequential containers like the vector, container adapters like stack and queue, and associative containers like sets and maps. And then we are going to talk about algorithms, okay? Sorting algorithms, searching algorithms, set algorithms, etc. So they all have implemented these, and this is a very complicated library, actually, standard template library, but I am not going to look at the details, all the details of the libraries. And some time ago, I remember there used to be classes about standard template library, like this class, 241 Object-Oriented Programming, 244 Standard Template Library of C++, and you had enough material for the whole semester, actually. So this is how large a topic is this, but I am not going to go into details of that, okay? So let's start, okay? Stack, queue, we know them, okay? Maybe we did not implement them, but we know what they do. And vector, we know what vector does. List, we know what list does. So idea is in our head, but we did not implement them. So if we know their interfaces, then it is easy to use them. We knew the interface of the vector and we have been using it. Later we have implemented our own vector. Yes, that's true. But that doesn't mean that without knowing the implementation, I cannot use them. Of course, I can use them. So today, that's what we're going to do. We are going to look at the interfaces of these, of all these classes. But first, iterators. As I said before, iterator is generalization of a pointer. In C or C++, we use pointers. My array of size 10, elements 1, 7, 10, 11, minus 10, etc. And if I have a pointer pt, and I could of course assign it to ARR, I could do this, right? Cout pt. That's what I can do, right? Or in a for loop, maybe in a for loop for int I from 0 to I less than 10 plus I and plus pt, I could of course do this. We like pointers, okay? By incrementing this pointer one by one, I will print out all these elements on the screen without using the scripting operator, right? Without using the scripting operator, the square brackets. I could do that. But let's say I like to do this. How about this? I like to do the same thing. Since I like this operator a lot. I like this pointer arithmetic a lot. I like to do okay, vector int IV 10, and I like to do this. Would this work? IV. Can I write this?
I think you can.
PT integer pointer PT is initialized with IV. What is the type of IV? IV is a vector, right? How can you assign an IV a vector to an integer pointer? No, it is not possible. No, this is definitely an error. How about this? How about this? Can I do this?
Yes.
Of course not. The same thing. What is the type of IV? What is an IV? IV is an integer vector, right? It's not an array, it's an integer vector. Think about this, okay. Think about this. Think about this. Instead of doing this vector, pf array int. Okay, I have an element of, I have a okay. Can I do this? Of course not. They are different types. One is an integer, the other one is a pf array. Okay. So let's do what Atakan says, okay? Atakan says that maybe I cannot do that, but how about this? I will do this. IV 0 and address. Would this work? IV 0 is an integer, and I take the integer address of that integer, and I point it with this my pointer. Yeah, it will work. This will work. This will fine. No problem. How about this line and this line? Would this work? And I will, let me tell you, yes, it will work. It will compile, but in the runtime, would this work? Does it work in the runtime? Let me put this back into my vector stuff.
I guess it's not so.
It may not work because we don't know how the vector class stores its integers. Are they consecutive? Are they in the memory like an array? Are they one after the other? Maybe the array is growing downwards, not upwards, right? We don't know, okay? We don't know. So you shouldn't assume this kind of stuff. Okay? Don't write this kind of code because vectors will never tell you that I am going to store my integers in a consecutive array like ways. Okay? Consecutive array like ways. Maybe even if the vector stores it that way, by coincidence, how about this one? List. List is a linked list. Okay. You know how the linked list works? Like that. Right? So I just follow the pointers like that. So 7, 10, 11. It goes like that, okay? And maybe here it's a null pointer. Oh, no. Okay, this one doesn't go anywhere. It's a null pointer. Okay, so we don't know how lists work. I mean, most probably it is like that, and this incrementing this PT is going to give us some trouble. We don't like it. So, but I like the idea of pointers. So iterators say that, okay, never mind, don't use pointers. Instead, use iterators. I will give you an iterator object, and that iterator object will work like pointers. Okay, they will work like pointers. You could use the plus plus minus minus operator. You could use the dereferencing operator. Everything will work. And the nice thing is that these iterators will work on any kind of STL class. Okay, let's see an example. The usage will be a little bit different, but it will be like that. Okay, so I have a vector here, line 11. I have a vector. Just pay attention to line 7. I have an iterator. What kind of thing is this iterator? You know line 6 using std vector, yeah? How about line 7? What does the line 7 say? I am going to use an inner class named iterator inside the class of integer vectors, okay? Vectors of integers. Okay, so when I say iterator, it means the iterator class, inner iterator class of the integer vector class. Okay, so I have a container, a vector integer, okay, integer vector, sorry. So I use 4 pushbacks to put 4 numbers in it. And I have an iterator. What did I say? Iterators are like integer pointers. So you read this like an integer pointer. So it's an integer pointer. But how would I initialize an integer pointer? I would take the address of the beginning element and put it inside the P. But this says that container.begin. So this integer vector has this integer vector container. Okay, this integer vector container has a function named begin. It returns a pointer or iterator to the beginning of the container, beginning of the vector. Okay, I initialize this P like that. Okay, I initialize that P like that. And then I increment this P one by one, and I use the dereferencing operator at line 19 to print its content out. So P is like a pointer actually. So the only thing is how I initialize P and how I end this loop is a little bit different. Just a little bit different. So there is a begin function that gives you an iterator to the beginning of the vector, and unless I reach the end of the vector, container end, I will continue incrementing this P. Okay. So this will work for a vector, and as you see, I don't use regular pointers, but my notation and by my performances too. My performance and my notation is very similar to regular C pointers. So they came up with this solution. And the nice thing is, almost everything that you do with the pointers will work. The referencing operator works, I print it out. And I am doing the same loop again from the beginning to the end. I assign 0 to all the elements of this vector, and I print them again. No problem. Okay, everything works. Let me show you something, okay? Let me do this. Instead of vector, let me make this a list, a double linked list. Okay, what's a double linked list? Double linked list is, of course, I think I drew it a few minutes ago. Okay, like this 1, 2. I think it has 4 elements, right? It had 4 elements. Okay, good. So I put numbers in it: 10, 7, 5, minus 10. And of course, it's a double linked list. This is a double linked list. If I put these numbers in it, I will see a picture like that. But maybe the vector is like an array. I don't know, but I'm just guessing. 10, 7, 5, minus 10. This is the vector. Doesn't matter how I store them in the memory. Doesn't matter how I store them in the memory, like a vector or like a linked list. Doesn't matter. Okay. This code will work. List is a container. Okay, container is a list, or container is a vector, or container is, what do we have other than those sequential stuff? Let me see. Okay, I have list, I have vector, and I have deque. Deque works that way too, or array works that way too. Okay. Okay, so these are all the stuff that can, if I replace it with these, then they all will work. So that's why we say that iterators are generalizations of pointers. Pointer arithmetic will work only on the arrays, regular C arrays, C++ arrays. But iterators will work on STL classes, all the sequential STL classes. Hussein is a question: using begin to print vector. Okay, begin. ITC out IT. How is that? Auto IT begin. IT not okay. IT. What is different? Well, it is not different. What you are saying is, okay. He says that, what is the type of it? Okay, I don't have to write it that way. Usually, we write it this way. The type of P is an iterator, but that iterator is a inner class for the std vector int. Okay, so you have to type the whole thing here. Okay, that's one thing. But if you don't want to do that, no, I don't want to type the whole thing, use the C++ auto mechanism. You will say that the type of P I don't know, but whatever begin returns, it will be my type. So usually we do it that way. So what Hussein says, that's right. Okay. Hussein, did I answer your question? I wish your microphone works. Okay, I wish all of your microphones worked. Unfortunately, either you have some problems with your tongue or there is a technological problem. I don't know. Okay, so Atakan has, can you repeat what we do in line 7? Atakan, what we do in line 7 is exactly the same as what we do with line 6. Okay. Okay, so with line 6 and line 8, we are saying that I am going to use these two classes, vector and list, from this standard namespace. So when I say list, it means this list. Okay, line 8 and 13 are related. When I say vector, it is this vector. When I say iterator, it is the iterator of the vector class, the inner iterator class of the vector class. But usually I prefer doing it with like line 19, or the better thing is maybe line 20. Line 20 is the better thing. I don't have to type all that crap. Okay. Any other questions? So that you got the idea of iterators. So let's look at iterators. So one thing. So as you see, there is a forward list. Forward list is like a list. Can somebody guess what this forward list is? Can somebody guess the difference between the list and the forward list without looking at the documentation? Yes, exactly, Bahadur. It is a single linked list. It is not like this. Okay, so this is list, and this is forward list. Forward list. Of course, with the forward list, I need to eliminate these arrows. So, okay, good. But if I have a forward list, I know how this plus plus p works. I would increment my pointer from one way to other. How about this minus minus p? How am I going to come back from a forward list? If my pointer is pointing to, okay, if my pointer is pointing to p, like that, okay, with a list, it is easy to follow this link to go to here, and it's easy to follow this link to go to there, right? Both directions are okay, but with the forward lists, if my p points here, I know how to go forward, but how am I gonna come back? How am I gonna... Gökbey, exactly, that's a very nice answer. We can't come back. So for some of the iterators, okay, minus minus is not going to work, unfortunately. For some of the iterators, minus minus is not going to work. Okay, let's take 10 minutes of break. After the break, we will continue. Efendim?
Hocam iyi günler. Kostyek'ten arıyorum, Murat Küçük ben.
Buyurun.
Bir inovasyon projemiz vardı hocam. O bir görüntüler üzerinden COVID-19 teşhisi konulu
Evet.
proje. Bunun izleyicindeki faaliyetleri yürütebiliriz.
Firma nerede? Ya da firmanın ismini alabilir miyim? Yani bir şey olmasın, çıkar çatışması. Ben Prote'ye ben danışmanlık yapıyorum ya. Yani çünkü bu civarlarda birileri tıbbi bir şeyler yapıyorsa genelde tanıyorumdur falan. Onlarla sıkı ilişkilerim var benim. Öyle. Mhm. Okay. So some of the iterators won't be able to do everything that we can do with the pointers, regular pointers, such as coming back. Plus plus will work and minus minus will not work. So we will see these kind of differences in a few minutes. Mehmet Avni has a question. Should we create a destructor and use delete operator for list stack? Should we create a destructor? Mehmet Avni, we have been using vector class. Did we delete any vector objects?
I think so.
Where did we delete any vector objects?
I mean, I think there was a question in the exam about deleting vector.
The question is about exam, but in the midterm exam?
No, it's not about midterm. I mean, it's about this kind of step.
If you are using a, I mean, I don't understand this question. This is a list, right? Did we use any destructors in here? I mean, the destructor of list is defined for the list class inside it. Of course, there is a destructor, but we don't know about it. We don't care because that information is hidden from us. If you are writing your own list class, then of course your responsibility to write necessary functions such as the copy constructors or the destructors. I mean, how can you write a destructor for list, for this list, line 13? It's not your class. I think I don't understand your question.
Actually, I meant if there is an, I mean, hidden structure for this kind of thing. I get it now.
Okay. Okay, if it is not clear later, maybe you can ask. So the iterators are like that, okay? A generalization of the pointers. That's the idea, but sometimes for a specific class, some of the pointer operators may not work. For example, that minus minus will not work for the forward list. Okay. So let's continue. As we said before, with the operators, I can have plus plus minus minus equal to not equal to, okay, the referencing operator or the arrow operator too, okay. So they all will work, okay. But how to initialize an iterator is different, a little bit different from the pointer initialization. We initialize with begin and we check our pointer against this c.end. Okay, these are not pointers, these are iterators.
Sir, can I ask a question?
Sure.
Compare operator is comparing address or value?
Compare operator is comparing the two iterators. Okay. For example, here. Okay. Auto P1 is container.begin. And auto P2 is container.begin again. Okay, if you say P1 is the same as P2, this is true. Yeah, right? This is, yes, this is true. But if you say P1 is equal to plus plus P2, then this is false. because they are pointing to different places now, right? Okay, so that it's like pointer comparison. I mean, if they are pointing to the same position, then they are true. Then it is not.
Thanks, sir.
Very similar to pointers. Okay, let's look at the other examples from the book. Number 2, I have a vector of character. Okay, character vector. I push back A, B, C, D, and just tell me what would this print. Okay, see, as you see, the index operator works for this vector. I mean, no problem. I mean, we have been using this throughout the semester, okay, from the beginning of the semester. So this vector works like an array. Yeah, we know that. How about this then? I have an iterator P. Okay, iterator is like that, or you could say auto P. Yeah, and this container too works, but this one works too. As I said before, P is like a pointer, and with a pointer you could use the index operator, or you could use the pointer arithmetic. P plus 2 is another iterator, and I dereference that iterator. It will work. Okay, it will work. And I put P again, the container begin, and star P, dereference P will work, of course. P plus plus will print the first element. Okay, sorry, this one will print the second element, this one will print the third element. Now I will come back and I will print the second element again. So I did more pointer-like arithmetic now. Okay, whatever, as I said before, whatever works with the pointers, it will work with the iterators, unless there is a restriction. By the way, they forgot to put lots of stuff in here, right? They forgot to put comma, plus, comma, minus, and arrow operator, and index operator. What else did they forget? I do. Okay, what things, what kind of things that we do? What kind of operators are there for the pointers? Plus, plus, minus, minus. Of course, assignment operator works, right? And I think stream insertion works too. It prints out the value of it. I am not sure about this one. I am not sure about this one. Okay. So these are all fine. These are all fine. Again, I'm going to repeat the same thing maybe 10 times. Iterators are generalizations of pointers. They are generalized to work with. STL classes, container classes. Container is, as the name implies, it's a data structure to contain some data. Vector is a sequential container. List is a sequential container, okay? Not all the containers are sequential. There are some associative containers, and we will see examples of it. Let's continue with the slides. Okay. From beginning to end, I process star P, and this will work. And I think this is the same example that I showed you. Okay. The vector iterator types, each container, the vector or list, has an iterator inside. Okay. And this is different from this one. Okay. This is different from this one. This iterator is a different type than that iterator. One of them works for the integer vectors. One of them works for the integer lists. What they do is under the hood is very different, but we see it as the same thing. We see it as the same thing. Can we make the iterator null pointers? If we do, does it affect the vector? No. Null pointer is a pointer. Iterator is an iterator. They are not compatible. You cannot assign a pointer to an iterator. No, they are different. Okay. If you like to use it as like a null pointer, okay, you may think it as this way, okay. When you declare, let me do this, okay. Okay, so when you say iterator P, this is like a null pointer. I don't know where it points to. Line 22. But after that, I am initializing it with the beginning of the container. Okay. No, the Mehmet Hussein, that's a good question. What happens if we reach the end of the container? Okay, like that. What happens if I reach the end of the container and I continue doing the plus plus? I mean, you may increment plus plus as much as you like, but when you do the dereferencing, you will be in trouble. I mean, the behavior is very similar to what you get with the arrays. Okay, so you are not doing a good thing. You may or may not get a runtime error. You may or may not get a segmentation fault, but whatever you are doing is a bad thing. Okay, and if you are asking if it is range checking is done, I mean, when you do this plus plus, I am out of the range. No, you will not get any exceptions or runtime error like that, because that would be too expensive. Because every time I do plus plus, I have to check if my range is okay. That would be expensive. And the idea of pointers is they are efficient, right? They are fast. Instead of using the square brackets, I am using the stuff. Okay, good. Kinds of iterators. There are different kinds of iterators. What do we mean? I mean, yeah, well, for the integer vector of integers, okay, there is an iterator. Vector of list of integers, there is an iterator. But inside the vector of integers, there are different kinds of iterators. Okay, there are different kinds of iterators. And we will see some examples of it. Okay, for example, there are forward iterators that can go forward plus plus. Bidirectional operators can go both plus plus and minus minus. This is minus minus. Okay, plus plus and minus minus. And there are random access iterators. In the random access iterators, both plus plus, minus minus, and the index operator will work. Okay. So that depends on the type of the class that you are working on. Okay. And sometimes there are constant and mutable iterators. You might say that I need a constant iterator. I am not going to modify anything, okay, with the constant iterator. And let me show you some examples of it. Maybe directly from the book example. Not this one, but maybe this one. Okay. So this one is a reverse iterator. You know this one, line 19, 20, 21. Starting from the beginning of this character vector, start from the beginning until the end, print it out. Start from the beginning until the end, print it out. That's one thing. Reverse iterator. I have a reverse iterator here. It's very interesting. Actually, let me get this here. Why don't I use this? Okay. RP is a reverse iterator inside the vector of characters. And there is a function named rbegin, reverse begin. Okay, there is a function named rbegin, reverse begin. It points to the end of the container. And when you increment this pointer or iterator, it will go backwards because it's a reverse iterator. And you don't check this against the container.end, but you check it against the container.rend, reverse end. So this is a reverse iterator. You start from the end of the container, and when you increment this iterator, it goes backwards. That's called reverse iterator. So there is a begin function for the vectors. There is an rbegin function for the vectors again. There is an end function and there is an rend function. If we go to the definition of the vector, again, these are the iterators: begin, end, rbegin, rend. Okay? 4 functions. They would return iterators for you. Okay? So if you like to go from end of the container towards the beginning, then that's what you're going to do. Of course, if we go to, and I'm going to talk about these in a few minutes. If we go to the class forward list, by the way, forward list is only available for C++ 11 and afterwards. Okay. It is not available with C++ 98. If you go to, okay, if you go to this class definition, forward list, as you see, I don't have an rbegin and rend. Why? Why is there no rbegin and rend? Can anybody take a guess? There are no rbegin functions for the forward list. Gökbey, you know this class very well. Yeah, Gökbey knows his single linked lists. Yes, exactly. Because we can't go back in forward list. There is no coming back. Okay, there is no coming back. Okay, good. What else? Let's look at the list class, and the list class will have all the begin, end, rbegin and rend. Let's look at this begin function. It will return an iterator. Okay, it returns an iterator, and I can use that iterator to do whatever I need. But I like to go to the, okay, I like to find what can I do with this iterator, and I like to find it. Member functions are these. Begin returns an iterator. Okay, list int iterator. Maybe I should go back and check that iterator. Okay, inside that iterator, okay, it's a bidirectional operator. Let me go to that bidirectional iterator to see. Yeah, as you see, list has a bidirectional iterator. With the bidirectional iterators, these are available. plus plus minus minus, assignment, dereference operator, arrow operator, comparison operators. But as you see, there is no index operator. Okay? There is no index operator. Because list, the class list, doesn't allow you to access a member randomly. You don't do random access with the list. Okay? If you go to the random access iterators will tell you that everything is possible, okay? Including dereferencing, plus, plus, minus, minus. Also, this kind of pointer arithmetic is possible. A plus n, n plus a, and etc. Less than, greater than is possible. And indexing is possible. Okay? So this part will belong to the random iterators. Okay? Okay, so that's what I'm trying to get at. Q has a random access iterator. List has a bidirectional iterator. Forward list has forward iterators only. Okay, lists they don't have any random access operations. Okay, good. Gökbey has a question. Sir, why do we need our begin and our end? We don't we start with and then decrease the iterator? No. And does not. And okay, that's a good question. The vector iterator and does not point to the last element, but it points to the element past the last element. Okay. And for some classes, coming backwards from the past the last element is not possible. And there are some compiler complications too. Some compilers produce code to point to the last element, and that's going to be a problem. That's why they made that decision. Yeah, our begin and our end sounds stupid. Why can't we do the same thing, starting from the end and coming back one by one? For some compilers it doesn't work, so they made that decision for making this our begin and our end possible. Okay, so let's go back. And the reverse operators, as I said before, it is not available for some of the classes. Okay, take a guess. Do you think what kind of class is I'm trying to find the containers. Okay, here is my containers. Okay, what kind of class is a stack? Can you tell me what kind of operations I can do with a stack? What kind of operations I can do with a stack? These are not more. This is not my stack. Let me go there. Just a minute. I'm trying to find the. Okay, this is a class stack, and this one class template. Okay, here it is. So the member functions of the stack are empty, size, top, push, and that's it. Okay, pop. These are the stuff. So you pop, push, and that kind of stuff. And I would ask are you empty or not? Okay, are you empty or not? So does it have any iterators with the stack? It looks like it doesn't have iterators, right? Relational operators. So they did not define any iterators for the stack. Why it doesn't make sense? Because what am I going to do with the iterator for a stack? I cannot do plus plus minus minus, right? So Stack doesn't have any of them, but Q should have it. Where is Q? No, Q is the same thing. This is just first in, first out, right? First in, first out. Let's see if Q has the iterators. No, it looks like it doesn't. It looks like it doesn't. Even for C++11, no, it doesn't. Okay, so some container classes, they don't have the iterators. Okay, other than the reverse iterators, we have so I think Gebze was asking this question: container and container begin. The book says might work on some systems, but not most. Okay, so just to make sure that this will work, you use R and R begin. Gebze was asking this question: why don't we use this code? The answer is it will not work for some of the systems. Implementation is different. Okay, so reverse iterate is there. Compiler problems. I think this is an example. See, all the book code says that I am going to use this iterator in the code, but I prefer this way. Okay, I prefer that way. I prefer this way because not all the iterators in my program are going to be character vector iterators. Okay, I could use integer vectors, and maybe I could use integer lists. Each one is called an iterator. So using this is not a good idea, but declaring your pointer or iterator that way explicitly in your code is a better solution. That's my preference. Okay, so as we said before, instead of doing this, maybe you could use auto PV begin. It is readable, it is easy to write, and you don't have to think about what is the type of this thing, etc. Okay, and you don't have to say anything using statements, using declaration, because auto is going to take care of that with that begin. Okay, good. So these are the iterators, and the other thing is this. Other thing is. Let me see if I have a example for the. Okay, these are the list stuff. We already did that. And these are the stack. Push and get. This is an example for the stack. Okay, example for the stack. A character stack. I push and I get and push unless I get this nameline character from the keyboard. I keep pushing onto my stack, and then I keep popping from my stack. Okay, print out the top element and I use pop. Print the top element and pop until my stack is empty. I keep doing this. As we just checked, we don't use iterators with the stacks and queues because they are not available. Question: when we use two-dimensional vectors, how do I use iterators? Well, what kind of iterator is this iter? Okay, let's say auto, or let me write it explicitly. What kind of iterator is this iter? Okay, it's an iterator of lists of integers, right? You are saying that if I have a list of lists, if I have a lists of integers, then this is going to be a iterator of lists of lists. Okay, so each element of this container, okay, list object container, is going to be another list. So this iterator is going to point to a list, not to an integer. Okay, so if this stream insertion operator defined for a list, then it will work, otherwise it won't. Okay, so each one is a list. Each of your element is a list. So you may define an iterator for each of them. Let me try to write some code in there then. Okay, then maybe this is going to be exactly what you are asking. Okay. This is going to be std list of integers, and then integers and iterator 2 is what should I write here? I should write iterator begin. And then if the iterator 2 is not equal to, what should I write here? If iterator 2 is not equal to can anybody guess? You guys are back? Can you hear me?
Yes, we can.
Okay. So while you are away, I completed my code. Okay, maybe I should make this a little bit smaller so that it fits. So the outer loop iterates over the lists. The inner loop iterates over each list. So I start from the first element of this list, which is a list again. I get an iterator, and this iterator is a integer list iterator, and I will go until I hit the end of that object. Okay, and I increment this number by one by one. No, yeah, okay, one by one, and each time I get a new integer. Okay, so that's the answer to your question, I guess. And I don't know what Hussein Ömer says it's null. I don't know what it says. Okay, good. So let's go back and let's look at the documentation of the vector again. Let me go to the vector documentation. No, before go to a vector documentation, maybe I should continue, and we looked at the stack. We looked at the set. We don't have that thing. Yeah, okay, here it is. There are constant iterators. Okay, these constant iterators are available in vector or in list or dig, okay, or sets. Constant iterator means that you cannot change the value of the pointed elements. Okay, let me go here, the first example. Okay, the first example that we did. Okay, and I am going to do this. I have a pointer P, but it's not an iterator, it's a constant iterator. Okay, it's a constant iterator P. So this is like, what is this like? It is not like integer pointer anymore. It is not int star P, but it is something else. What? Line 19. What is the corresponding pointer declaration? It is not int star P. It is something else. Exactly, Yakup Talha. Okay, it is const int star P. Okay, so is it okay? Is it okay to write line 23 like that? Can I write it? Line 23? Oh, of course, I shouldn't do P, auto P anymore. Can I write line 22 and 23? Yes. Why? Because P is an iterator, but it's a constant iterator. It says that I am not going to modify the elements that I am pointing to. How about line 30, line 29, and line 30? Does line 30 work? How about line 30? Does line 30 work? No, are the three correct answers? No, why? Because I am trying to modify it. So this is a constant iterator. With the constant iterators, I promise that I am not going to modify anything. So line 30 will not work with the const iterators. Okay, line 30 will not work with the const iterators. Later, with the introduction of C++ 11, they have introduced these these. Let me go to vector again. Go to vector. Okay, this one. Later, with the C++ 11, okay, they say that we are going to use a separate begin and end functions for the constant iterators. Okay, we are going to use separate iterators for the constants. Okay, so there is a C begin C end, CR begin CR end, constant reverse begin, constant reverse end functions. Why? Because let me try to do this. Let's say I don't have this line. If I put auto here, okay, what is the type of P? Is the constant iterator or iterator? Okay, compiler has difficulty to figure that out. So it assigns an iterator, regular iterator. Okay, it assigns a regular iterator. So previously, before C++ 11, it was like this. But before C++ 11, we didn't have the auto keyword. We didn't have the auto keyword. Now we have the auto keyword. This is going to create a problem. So let's do this. Constant r begin and constant begin and constant end. Now I know that p is a constant iterator, right? So that's the difference. Okay. So if you like to use auto with p, and what you need is a constant iterator, and if you are using C++11, this is what you're going to do. Let's go back to this vector and let's try to go back. Okay. So these are the types inside the vector. Okay, I think I am back. Yeah, I am back. So let's look at the other stuff that we did not look at yet. Okay, member functions, constructor and constructor, destructor. We know that. Assignment operator, we know that. All the iterator related stuff, we know these. And the capacity related stuff, we know all of them. And the access elements and the modifiers. There are insert, erase, swap, and clear, etc. Okay, so we know all of them. The only thing that we don't know is this allocator stuff. And allocator stuff is it has something to do with how do I do the dynamic allocation and how do I deal with that kind of stuff. Okay, so you can go into details of how the vectors work and you can modify that functionality. I think there is an example here. My vector and there is a pointer. Get allocator, allocate 5. Allocate an array with space of 5 elements using vector allocator. And I'm constructing some elements of it. So going into the vector and maybe changing the behavior of the regular vector allocation and that kind of stuff. Okay, so I am not going to, what did I say? STL is a complicated library. If I like to go to the details of every class, all the classes, that's not going to be good. Okay, that will be too detailed. I will skip that one. Okay, so that's about it about the iterators. Let's go back and let's try to study the containers one by one. Different kind of data structures, lists, queues, and stacks. Okay, each is a templated class. So you may have list of integers, doubles, and my class, my money or bank account, etc. Doesn't matter. And each has its own iterator. Some of them are bidirectional. Some of them are random access. Some of them are single directional. Okay. So the sequential containers are the first ones that we are going to look at. What are they? Okay. They are vectors. They are lists. They are digs. And they are that kind of stuff. Okay. So list is a, okay, this one says that STL has no single linked list. STL didn't have it before C++11. Now with the C++11, it has single linked list, both double linked list and the single linked list. Okay, and this is the definition of single linked list and double linked list. I'm not going to talk about it, and this is an example. We looked at this example before. So the interface of all the STL classes are very similar. Okay, like we have the pushback for the vectors. We had the pushback for the list. We didn't have push front. We didn't have push front for the vectors, but we have push front for the lists. Okay, let's look at this one. Go back to the vector. Okay, pushback, pop back. There is no push front and pop front. Okay, it is expensive to push something in front of a vector. and it is expensive popping from it. Okay, but if we look at the lists, with the lists, you will have both pushback, pop back, push front, pop front, push front, pop front, and pushback, pop back are there too. Why do we use constant iterators? Can we use it for going to head node of a single linked list? Well, I mean, why do we have constant pointers? We use constant pointers so that nobody changes the container contents. And if I have let's say I have a function, let's say I have this function void f, and it takes a constant. That's what we do, right? If I take a constant vector, and in my code, if I say auto p v dot begin, okay, when I do this, I don't want to be able to do this. Why? Because if I do this, this C++11 compiler will tell me that this v is a constant vector. You cannot get a non-constant iterator for it. So I have to take a constant begin. If you have a constant begin, this p will be a constant iterator. With the constant iterators, you cannot do that. So line 47 is going to produce a compiler error for you. And I don't understand your second part of the question. Can we use it for going to head node of a single linked list? Yeah, why not? I mean, this could be a single list. Of course, I can't still do that. What can I do? I could do maybe this. Okay, so we looked at the lists, and similarly there are other classes like the container classes other than the list queues and list. Let's look at this class Deek. It's called Deek. Okay, Deek is a class double-ended queue. Okay, it is in between. Okay, double-ended queue. Are sequence containers with dynamic sizes that can be extended or contracted at both ends. Okay, they are like vectors, but vectors can extend from the end, not from the beginning. This one is like it can extend in both directions. Okay, so it is between a list and vector, or maybe it is both list and vector. Okay, so what kind of since it can expand from both sides, pushback and popback is available, and push front, pop front is available. And if you look at the iterator is a random access iterator. So with the list, we didn't have the random access iterator. We have the bidirectional iterator, but list had the both expansion capability at the both ends. So this Deek is doing both, all of them. It is both random access, it can expand from both ends. Of course, since it is trying to do everything at the same time, it is not as efficient as vectors when it comes to random access, and it is not as efficient as expanding from both ends when it comes to expansion. Okay, dig is something like that. Okay, we looked at the forward list, map and queue. We are going to look at it. Let's look at set and stack. And I think I am out of time a little bit, but I don't want to stop here. Okay, so these are container adapters. Container adapters are like this. Stack and queue. What are the operations for stack? Tell me the operations for stack. Push and pop and empty, right? These are the three operations. I push something, I pop something, and I do empty. For this kind of simple stuff, I don't want to implement the whole thing. Maybe I could implement this stuff myself using a vector of integers. Okay, the definition of stack is something like this. I need a integer stack, but I am going to use a vector of ints under it. Okay, vector of ints under it. Let's try to write this. Okay, let's write this. Okay, template class T, comma, class R by default is going to be vector of R's. Okay. Class stack. This class stack will not have many private data members. I am going to write the private data members at the beginning. I don't want to do that, but let me write it at the beginning so that we know what it is. My data is going to be class R, and it is going to be my data. For the public part, my constructor is going to be stack, and at the beginning I will not do anything, right? I won't do anything. For the push, void push is going to take a constant T object, an element. Let me implement this real quick. I would say data dot push back, data dot push back E. That's it, right? If it's a vector, okay, vector R, I am pushing back the element at the end of this vector. How about the other one, the pop? T, pop, it will not take any parameters. These are not constant, of course. Return data dot pop back. Okay. How about empty? Empty returns a boolean. If the stack is empty, it will return true. Empty. Of course, it is a constant function. What am I gonna say? Return data dot size is equal to 0, right? And I guess that's the whole class, templated class of stack. So these kind of classes are called adapter classes, okay? Because it doesn't implement everything itself. It adapts this underlying vector class or any other class, whatever it is, okay? It adapts the underlying class to do whatever it needs. It needs just 2-3 simple stuff, and those 2-3 simple stuff can be very easily implemented using this private data. I don't need the big 3. Why? Because I don't have any pointers in it, right? So the default assignment operator for this R data will work. Okay. Whenever I need objects of this stack, I can say stack of integers S1. Since I did not specify the second one, it is taken as a vector of integers. Or I could say a stack of integers which is going to use a list of integers as an adapter, S2. Okay. So stack is something like that. Queue is something like that too. They are implemented using this way. Okay. Any questions about the stack and queue stuff? This is a very well-known object-oriented design principle. Okay. Whenever possible, or design pattern. Okay. Whenever possible, use adapter classes. Because with the adapter classes, it's an example of code reuse, right? Composition. You are using other classes to do your own work. And your code becomes so simple and it is understandable. Do this, prefer this wherever it's possible. And I am exposing this information to the outside world so that they can prefer their own. The class that works the real work. It could be a list, it could be a vector, it could be a dig. Okay. It could be, how about this? Can I do this? Stack of integers, but I like to use a money class here as 3. Can I do this? If I do this, what would happen? If I do this, first, can I do this? The answer is no. So where would I get the error message? Where would I get the error message?
Push, pop, and empty method.
Yeah. Push back, push, pop back, and size will not work on the money objects, right? So when I do this, I will have this problem. So this will not work. But this and this will work. Okay, good. So that's it for today. Tomorrow morning I will finish up with templates, standard template library. And next week and the other week we are gonna do Java. Okay, so 2 weeks are enough for Java because you know C++ very well. If somebody knows C++ very well, 2 weeks will be just enough to understand the Java. But as I said, you need to know C++ very well. And it is a very good time to catch up and study hard and try to understand everything about C++. And the nice thing about Java is when we start talking about Java stuff, you understand C++ even better. So don't skip Java classes, okay? It will make you better C++ programmer, and it will definitely make you a much better object-oriented programmer. Okay, so next 2 weeks are important. Study as hard as you are studying for the final exam, so that you know your C++ stuff. That will make it much easier to understand the Java stuff. Seeing the difference between C and C++ and Java will be helpful for both of your Java programming and C++ programming and programming in general. Okay. Okay, Nejdet has a question. How do we send our iterators like a function parameter? I should write. Well, I mean, this is just a type, right? Where is my iterator? This is just a type. Yeah. So this is a const. Okay. I am sending a single list, or I think it is not single, it's forward list. Doesn't matter what it is. Okay, this is a forward list. Like I am sending a forward list, I could send a vector iterator. It's just a type. Okay, so whatever you are, the second one that you are saying. Okay, that's it for today. I will see you tomorrow morning.